Hello, my name's Madeline.
And my name is Rachel. Let me tell you about our project. The title of our project is Let It Rise. In our experiment, we tested different yeasts and fermented foods to see how much CO2 they released. This title represents the CO2 being released.
Next, you may be wondering why we chose this project. Well, we both really enjoy baking and knew that we wanted to do a project that included fermented foods and yeasts. We were also wondering what the difference of them would be kept at 2 degrees Celsius and at 26 degrees Celsius. So in our experiment, we knew that we wanted to compare them to see if there even was a difference.
The purpose of our experiment was to test and compare the amount of CO2 released by active dry yeast, quick rise instant yeast, homemade yeast, sourdough, kombucha, kimchi, and sauerkraut. We did this at both 2 degrees Celsius and 26 degrees Celsius to see which temperature would result in the most CO2 being released.
In our project, we had 2 different types of procedures. We had a general procedure, and then we had a specific procedure based on each different type of fermented food or yeast. Our general procedure went off with starting to collect 7 different bottles and labeling them with the type of fermented food or yeast that would be inside of them. Next, you have to add half a cup of the nutrients, including the fermented food or yeast, to each bottle. Then you're going to attach a balloon on top and seal it using an elastic. You're going to let them sit in front of a measuring board for 1 week. You will measure their height, width, and general observations each day. Next, you're going to compare these results, and you're going to repeat this experiment at 2 degrees Celsius to see if you find a difference.
Let me tell you about our results. The tallest balloons were a result of the quick rise instant yeast and the active dry yeast at 26 degrees Celsius. They tied with a height of 13 centimeters. The widest balloon was a result of the active dry yeast at 2 degrees Celsius. It reached a width of 10.5 centimeters. And overall, the active dry yeast at 2 degrees Celsius produced the most CO2. And you might be wondering how our results can be applied in the real world. Our results could be helpful for bakers, chefs, and people like us who are interested in yeast and fermented foods. You can adjust which fermented food you use, knowing how much CO2 it will release. And understanding the amount of CO2 it will release affects how dense the bread would be or how fizzy the fermented drinks are. And our results would help increase your knowledge and help form an outcome that you desire.
Not every part of our project was always easy, and we did encounter some road bumps along the way. One of the biggest ones being that not all of our fermented foods or yeasts released carbon dioxide. We think this is because they released carbon dioxide in their manufacturing process when we didn't have access to them. We found that the sauerkraut, kimchi, and kombucha did not release a measurable amount. Another thing that we encountered was that we had horizontal grid lines on our measuring board, but we didn't have vertical ones, which made it a little bit hard to tell how wide the balloon was every day. Finally, another thing that we found was that the stores did not sell instant dry yeast. They sold quick rise instant yeast and they sold active dry yeast, but they didn't sell quick rise instant yeast. We think this is because the quick rise instant yeast is a better version of the instant yeast, so it wouldn't make sense for the manufacturers to solve it. To solve for this, we added sauerkraut to our experiment. Also, to solve to not having vertical grid lines, we used a ruler to measure the width every day. In the future, we would want to do more research about how the temperature affects different types of fermented foods or yeasts. In our experiment, we compared them at 2 degrees Celsius and at 26 degrees Celsius. But we may even want to compare it at a cold temperature, a room temperature, and then a warm temperature to really find that perfect point for each different type of fermented food or yeast. We would also research if there are any other variables that could affect the CO2 being produced. In the future, we may also only focus on different types of yeasts and leave the fermented foods out. In the end, we may cook bread with each different type of yeast and compare the breads, seeing how large they got and how good they tasted.
We used the scientific method in our project. First, we asked a question. Our question was, which yeast or fermented food would release the most CO2 and at which temperature?
Next, we researched. In our research, we have each different type of fermented food or yeast and what they need to survive.
Next, we asked our hypothesis. Our hypothesis was when we test the amount of gas produced by different types of yeast and fermented foods and measure it using balloons, that sourdough will release the most CO2 at 26 degrees Celsius. We think this because it continuously releases CO2 over the longest period of time. It will release CO2 at 26 degrees Celsius because we know that sourdough is supposed to stay at room temperature. In the cooler temperature, active dry yeast will release the most CO2. This is because it reacts well to cold-proof doughs. Overall, fermented foods in a warmer climate will release the most CO2 because in the cooler climate, the bacteria may go dormant and not release CO2.
The next step in the scientific method was to experiment. In our experiment, we had different types of fermented foods or yeast at 2 different types of temperatures sitting for 1 week, and we measured their height, width, and general observations daily.
Next, we collected our data by writing in our notebook daily and observing the height, width, and general observations.
Next, we made an analysis. We found that active dry yeast kept at 2 degrees Celsius produced the most CO2, which also leads to our conclusion. If you'd like to read more about our conclusion, you can read it in our written work and in our slides. Thank you so much for your time. We really appreciate it.
Thank you.